Peace, power, and prosperity, family. This is Amir, the Chicago crypto hustler, Bitcoin block bully, coming to you once again, representing not only the Chicago crypto hustler and cryptonomic console pages, but also New Money Matrix podcast. What I'm going to be going over right now is showing people that just like in the commercial world that we live in within the United States, where you have either the public or the private side, and we already know that the two do not mix, not bring public into private or private into public. Within the cryptocurrency world, we also have the exact same thing. You have the public side, then you have the private side. You have public blockchains, private blockchains. As you can see, that's the first what we're going to be getting into first and foremost. Then you have public cryptocurrencies and private cryptocurrencies as well on top of the blockchains, not to be misconstrued with the blockchains themselves. And then, of course, you have public keys and private keys. So we see, just like the world of commerce, which when we look at cryptocurrencies in a whole, it is the equivalent to a new commercial world. That's why I call it the new money matrix. Um, I forgot, it was an individual whose video I was watching not too long ago, and he was breaking down how Dash cryptocurrency as well as other cryptocurrencies were actually trust. Now, you should definitely study what a trust is, but when we look at the blockchain and its purpose being to protect encryption and operate in foreign jurisdictions, because remember, the blockchain cryptocurrencies, you're able to operate in any jurisdiction with this crypto. Bitcoin is Bitcoin no matter where you go around the world. So it's the equivalent to being a global currency. So you are operating in foreign jurisdictions. And the most superior entity that I believe to operate within those jurisdictions would be the equivalent of a trust, meaning you're operating in the private in a one way, shape, or form. Now, you just like in the world of commerce in the United States, you're able to operate in both the public and the private. With cryptocurrency, you are also able to operate in both the public and the private. We're going to get into that now. First and foremost, what we're going to go over, and this is going to be short. I'm not going to get too in depth as I'm still studying this myself. But we're going to get into the difference between a private blockchain and public blockchain. Now, getting into the story, it goes on to state what is a public blockchain. Now, a public blockchain is a blockchain in which anyone can participate because it's open source and public to all who no one is in charge, meaning no one controls this blockchain. It's not centralized in any way, shape, or form, much like Bitcoin. There is no access or rights management done for a public blockchain, and anyone can be part of the consensus. And if you don't know what consensus is, it is a group agreement, meaning that anytime a transaction is done, it is the consensus protocol or the miners, or otherwise known as the nodes that connect the blockchain, that validate that transaction, and as a group agree that yes, this transaction was um, confirmed, or no, it was fraudulent and it was denied. So because of this, anyone at any given point of time can join, leave, read, write, and audit the public blockchain ecosystem, and the network will still okay, it says because of this, anyone at any given point of time can join or leave, read, write, audit the blockchain ecosystem, and the network will still be trusted. Trustless here means you need not set up a trusted party, third party, or entity to overlook the operations on this type of blockchain, and yet it will be censorship resistance. That is very, very, very incredible and amazing when you look at the way that we transact nowadays in the world of commerce. The catch is that this type of self-governed, decentralized yet trustless autonomy is ensured on the system by its method of decision making, which is very difficult or nearly impossible to tamper with. This decision making is called in this realm. Uh, this decision is making. This decision making is called in this realm. I don't know where we're going with that, but public blockchains like Bitcoin or Litecoin consume an enormous amount of energy, and that's the computer power that it takes to mine these tokens, or what they're speaking on. It also takes time and money because of the mining, and hence, in return, ensure trustlessness and remain tamper resistant. And they got links where you can read to know more how that happens on the Bitcoin network. We're not going to get into that exactly, but we're going to move right along. Bitcoin or Litecoin blockchain networks, anyone can do the following things that make it a truly beloved public blockchain. Anyone can run a BTC or LTC full node and start mining it, meaning that mining is not exclusive to any one person, any one creed, color, age, any of that. As long as you are able to get the proper electrical equipment, i.e., rigs, CPU, GPU, you are able to participate in the Bitcoin and Litecoin network and run full nodes and mine. Also, anyone can make transactions on BTC or LTC's chain, and anyone can review and audit the blockchain in a blockchain explorer, which is just the almost like the book that you look at in order to see all the transactions within the blockchain network. Now, what we're getting into is private blockchain. And a private blockchain is the absolute opposite of the public blockchain. It is because many functions that are open to all on public blockchain aren't open here to all. Here, one can't read, write, or audit the blockchain anytime unless one has the permission to do so. In private blockchains, the owner of the blockchain is a single entity or an enterprise which can override, delete commands on the blockchain if needed. That's why, in its true sense, it is not decentralized and hence can be called a distributed ledger or database with cryptography to secure it. But it is not all that bad because in comparison to a public blockchain, it is much faster and cheaper because one doesn't spend an enormous amount of energy, time, and money to reach a consensus here. But in the other sense, it is much less secure and closed as compared to public blockchain because it can be edited, written, or read, and when wished and deemed fit by the benefiting parties. And they got an example here of bank chain. Let me see, what is this bank chain? Okay, open platform for building blockchains. This is multi-chain. Subscribe for multi-chain updates. Multi-chain helps organize to build and deploy blockchain applications with speed. They got speed deployment, unlimited access, issue millions of assets on a blockchain, all tracked and verified on the net at the network level. Perform safe multi-asset and multi-party atomic exchange transactions, meaning you can swap within the blockchain. Let's see, developer friendly, customizable, and flexible security. Okay. I thought it was going to take us straight to the bank chain, unless that is the link to bank chain. But where were we? Okay. In such a blockchain, and we're speaking on a private blockchain, not everyone can run a full node and start mining. Not everyone can make transactions on the chain, and not everyone can review and audit the blockchain in a blockchain explorer. In simpler words, to make any changes in such types of blockchains, one needs special privileges and accesses. Going into a confusion and conclusion, the public blockchain, anyone can run a BTC or LTC full node. On the private, nobody can do that, or anyone can't just run a full node. Anyone can make transactions on the public. Anyone can't make transactions on the private. Anyone can review or audit the public blockchain, but anyone cannot review and audit the private blockchain. These differences are good to identify the right type of blockchain for various use cases that you may want to apply to, but there are a few similarities between both private and public blockchains that make it confusing for users to make the right choice. Some of these similarities are both types of the chains are decentralized and peer-to-peer. Both type of chains maintain a replica of the ledger at each node that gets updated with consensus. And both type of chains provide immutability at different levels though. Hence, instead of getting carried away by these similarities, let us always remember the above elucidated differences between public and private blockchain. He also goes in and says, in his opinion, despite the differences and similarities, public blockchains have the potential to disrupt many industries and revolutionize the world, but it doesn't mean that private blockchains will be useless. Private blockchains certainly have the potential to save millions of dollars for various industries by reducing many different types of behind-the-scenes expenditures that can be automated in a trusted way through the blockchain tech. And like I said, I've said many a time that big governments and corporations are not so much worried about, well, let me not use the word worried. They're more interested in the technology that the cryptocurrencies rest and rely on versus the cryptocurrencies themselves. So that was just a real quick explanation of the difference between public and private blockchains. Let's see if I can find anything else on here. That was sort of kind of short. I wanted a more in-depth look. If we can find, let's see, we can get just a little more. Let's see, public versus private blockchain on Hacker Noon. Let's see what they have to say. Or let's go on. Here we go. All you need to know about public and private blockchains. Let's see what they have here, what information they have. We know that the blockchain is what makes a blockchain special, blah, blah, blah. Okay, here we go. What is the difference between public and private networks? Let's see what they go into. What does public actually mean when it comes to blockchain network? Public, also known as open or permissionless networks, are those which allow anyone to join. Just like a public road or highway, anyone can use it. A car owner, a bike owner, a lawnmower owner, or a house owner. Contrast that with something like a railroad, which can only be used by a specific set of people operating a very specific type of equipment. Wow, I like that example. In blockchain terms, we could call this a permission closed or private network. Another way to think about the differences between public and private blockchain networks is to compare them with the public and private Wi-Fi network. Free Wi-Fi spots allow anyone to log on, but they malicious actors of law-abiding surfers, while private networks can be accessed by can only be accessed with a password. Before continuing with public and private networks, we'll touch on one small but very important topic: consensus. Having distributed database, you need to synchronize and align data on all nodes. What do you need? Okay, you go ask your mother. I'm doing. You go ask your mother because I'm recording right now. Okay. Okay, well, go ask your sister something. I'm recording right now. Now, can I help you? You have to wait till I'm done. I do apologize for that, family. I do apologize for that. I'm gonna have to get up and get her some cereal in a minute. Okay, go ahead. Close this door. Yes. I do apologize for that, family. Okay. Having distributed database, you need to synchronize and align data on all nodes. Let me go back and start that over. It says before continuing with public and private networks, we'll touch one small but very important topic: consensus. Having distributed database, you need to synchronize and align data on all nodes. This is achieved by consensus algorithms like Paxos and Raft for class distributed database, BFT and PBFT for private blockchains, or proof of work and proof of stake for public blockchain forms. Assuming you're crossing or you're using a Cassandra distributed database deployed to a server cluster, one of the first concerns you will want to address is node or network failure. Fortunately, tools like Paxos and Raft help a lot if you run into these sort of problems. Even if a node is compromised by a hacker, these consensus algorithms can do a pretty good job of handling the intrusion. However, Paxos, Raft, and other consensus algorithms, usual to classic distributed databases, heavily rely on majority vote. Thus, what is accepted by majority nodes is treated as truth. Imagine, though, that someone creates 1,000 new nodes and connects to your cluster, then starts intentionally issuing malicious transactions. This insidious strategy has come to be known as a Sybil attack. A hacker using this strategy has a good chance of cracking the consensus algorithm and tricking nodes on your network into accepting fraudulent transactions as legitimate. That's where the proof of work consensus algorithm comes in. Proof of work neutralizes the threat of a Sybil attack by forcing the attacker to spend more resources on attacking your network than they could expect to gain as a result of hacking it. At the same time, proof of work also provides a flat architecture for the network, where each node is equal to any other node and no selected leader exists, while all nodes can communicate directly, thereby maintaining consensus. Through two-level architecture, though two-level architecture exists, master nodes on Dash or verified nodes in the DPoS networks, we'll hold off on discussing them to a later article. Let me see, they're getting into smart contract. Okay, here we go. Public blockchain. Here we go. Public blockchain and private blockchain. Now, Public blockchains. Example of public blockchains include Bitcoin, Ethereum, Dash, Monero, Stellar, Neo, and NEM, or NEM or XEM, which is NEM. The number of public blockchain use cases is growing rapidly. The first industry to see blockchain's potential as a business solution was banking and finance, though many others began to adopt this technology after recognizing the potential and popularity of smart contracts. You've likely already heard of Ethereum, a smart contract platform which is widely used and has attracted a ton of media attention over the last couple of years. Besides transferring money, businesses can use public blockchains to also store document hashes of entire documents. Blockchain is a good choice for this sort of thing, as all transactions in the block are immutable. We can guarantee that a document exists, but we can also store some pretty important metadata along with the document, like when it was created, who created it. You can also store a ledger of some operations which should be public, accountable, and transparent, like change of ownership of precious Swiss watches, or ledger of politicians' tax records. Wow. You can also codify contracts between parties directly. You can create digital assets and transfer them to one another. And in logistics to prove the origin of goods, another good example of this would be food, which is sustainably grown without GMOs. This is the many advantages of using a public blockchain. Let's look at another example of how a public blockchain already works in practice. Those of us have experience in submitting apps to the App Store know that Apple requires you to purchase a developer subscription in order to publish your work on their marketplace. This subscription-based model probably sounds familiar to you all out there who have a Netflix account or subscribe to a newspaper or magazine. That being said, there's really nothing preventing companies from using a token-based model supported by the blockchain instead. Loom, for example, a platform for online game and social apps, requires developers who want to publish on its site to buy a couple of Loom tokens, which grant access to the Loom marketplace in a decentralized way. And I went into this earlier as far as the difference between coins and tokens. Right now, they're giving you an example of the use case of a token being the Loom token. It's not a currency. Businesses can also take advantage of blockchains like Bitcoin or Dash by providing their clients with the means of accepting payments in tokens, e.g., payment in Bitcoin. This gives ability to settle easy and fast cross-border payments and track all transactions for greater security against possible fraud. Now we're getting into private blockchains. While there are real benefits of using public blockchains, traditional businesses see few cons. You need to pay for each transaction in a given network eternal token, which means a business must first acquire these tokens itself. While public blockchains are reliable and relatively secure against malicious actors, the amount of time it takes to complete a transaction is large for using inside a private organization. Since a public blockchain is by definition visible to everyone, anyone can access the data stored on your network. Even if your personal data is transaction is encrypted, a motivated actor could obtain a lot of information about the parties involved in a given transaction from metadata or inference. For these reasons, companies looking for ways to improve their process and operations with blockchain technology tend to use public blockchains, i.e., closed or permissionless networks in which only a set of approved nodes can participate. As the name private blockchain implies, this type of network has a central authority, company, or consortium, which controls who can and can't access the blockchain. Sometimes private blockchains controlled by a set of entities, consortiums, or holdings are called federated blockchains. Contrast this with a private blockchain, which is controlled by just a single entity. I'll be referring to both federated and private blockchains as private for the sake of simplicity because they have almost the same properties. Using a private blockchain allows businesses to assume that no unwanted users can access the network, meaning many security requirements are no longer necessary. Remember, civil attacks. Well, in a private network, there's no risk that someone will be able to trick your network by adding a million malicious nodes. Given the lighter security requirements, a more effective consensus algorithm can be used on private networks, making transactions several orders of magnitude faster. Compare 7 to 15 transactions on Bitcoin or Ethereum to 1,000 in Hyperledger Fabric. What's more, transactions in private blockchain networks are usually free, as the owner maintains the node fleet and there is no need to pay for things like network maintenance or associated costs. Let's look at an example of how a private blockchain might work in practice. In our example, three banks create a consortium and want to make transactions amongst themselves. If they opt for the tradition, sounds like a trust. If they opt for the traditional option approach to manage money data between a discrete number of institutions, they'll probably set up a dedicated server for processing transactions, keeping logs, and providing a user interface to request different queries and statistics. Naturally, a question of trust emerges. Who's going to actually maintain this? Yeah, this is definitely. Who's actually going to maintain this server? One of the consortium members' IT departments or the IT departments from all consortium members working together. What measures would a consortium take to prevent one bank or administrator from cheating the others if they have full control over the server? How can other banks detect fraud? Fortunately, there's a good solution to these questions: a private blockchain. Let's imagine that instead of a centralized server maintained by one or multiple members of the consortium, the bank chose to use a private blockchain. Each bank would have its own server, and all three servers would be joined in a private blockchain network. Wow. Since each server stores the consortium's entire transaction history, and because the network uses a consensus algorithm when new transactions take place, no bank alone has the power to modify transaction records or create fraudulent records. A majority of the networks, two members of the banking consortium in our case, would be able to reject any corrupted or malicious transaction initiated by the remaining members. Since truth is dedicated by the majority of the network, there's no risk of faulty transactions being introduced into our transaction history. The same principle holds true if one of the bank's IT systems is compromised. Even if one server is attacked, it won't affect outside interbank transactions because the other two nodes of the blockchain will reject transactions from compromised nodes. So far, we've emphasized the benefits of a private blockchain, the benefits a private blockchain brings to the majority of members in a given network. However, what about the protections it can offer individual actors? Let's imagine that two members of a consortium decide to gang up on the third and create fraudulent transactions that advantage the former at the expense of the latter. In this case, the third bank could easily track when the malicious transactions were made and present a case to a higher institution using the immutability public transaction history as evidence. So, who's using a private blockchain? The typical uses for private blockchains include finance, logistics, medical data, user identity, asset ledgers, auction systems, and supply chain tracking to detect counterfeit or stolen goods or ensure the origin of a given product. And right here, they're comparing public versus private blockchains. Let me see. New members, anyone can join. Pre-approved members can only join on the private. Transaction creation, anyone can create transactions on the public. Only members can create on the private. Transaction fees on the public blockchain are low, but they're high on the private. Transaction cost is high on the public, but it's low on the private. Consensus on a public blockchain is proof of work, proof of stake, and DPoS. On a consensus on a private blockchain is PBFT and proof of authority. And just so we know exactly, let's see. It stands for, want to make sure I'm right with my word. Yeah, practical Byzantine fault tolerance, or the PBFT model primarily focuses on providing a practical Byzantine state machine replica that tolerates. There's a lot of computer talk, but let's get back to the differences. So that is the consensus that the private blockchain uses, PBFT, or proof of authority. Trust with the public blockchain requires no trust between members. On a private blockchain, nodes need to trust each other. Identity on a public blockchain, they're anonymous and pseudonymous. On a private, there are known identities. Assets on a public blockchain are native assets. On a private blockchain, there are any assets. USP on a public blockchain, they're disruptive and it's a new philosophy. And in the private blockchain, you have cost cut. Platforms for building a private blockchain network. Okay, there are many different software platforms, libraries frameworks, and other tools for building blockchains. While public blockchains are usually forked from existing chains or written from scratch, private chains are usually built using tools available on the market. The most popular tools for creating private blockchains are Hyperledger and its associated byproducts, the Hyperledger Fabric, Hyperledger Sawtooth, and a Hyperledger Indy. Corda, which offers features designed for use in banking. Some banks use Corda for its speed and bank-oriented features. Interesting. Exonum, which was used to create ledgers for land and state-owned property in countries like the UK and in Georgia. Wow. Quorum, Ethereum, and Megan, though best known for their use in public blockchains, can be forked and redeveloped for use in a private blockchain. While a lot of businesses use these technologies to get started, it's important to keep in mind that they don't provide a one-step solution. You'll need to reserve some time and money for development and testing. And it's almost like when you are learning to operate, going from operating in the public to operating in the private in the world of commerce in the United States. It does take a amount of extra work for you to really comprehend how to function. An important aspect of building your own private blockchain is how to codify your business logic. Let's use an analogy. Let's see how much more. Okay. I don't want to see how deep they're going to go because I do want to get to the difference between public and private currencies also. I don't want to get too caught up in the sauce of public and private blockchain. Let's see. We'll use their typical analogy real quick. You can implement a super fast dedicated web server in the Go programming language, which does everything from handling network connections to managing complex user logic. Or you can split your application between two different technologies with their own domains of responsibility. Apache Web Server can be used to manage things like data transfer and connectivity, while PHP can be used to implement your business logic. The latter approach is ultimately more stable, as one small error in your business logic won't knock out your server. That being said, it's also definitely slower than an all-in-one approach which Go offers. On the other hand, having scripts separate from core web server logic allows you to change scripts representing business logic faster without recompiling and redeploying server software. Both approaches have been used to implement blockchains, and some technologies are already opinionated about what technology stack you have to use in order to set up the network. If you use Exonum, for example, you'll have to define all your business logic in the Rust programming language and compile it as a module in your blockchain node software. This is definitely a case of more control and flexibility of core blockchain functionality requiring more time and more expenditure as to fine-tune your chain. You'll need help from a developer who knows a way around Rust. The Hyperledger Fabric lets you codify business logic in Golang and JavaScript, which you can then wrap around these nodes responsible for the sort of logic with Docker. And in Quorum, an Ethereum clone for private usage, you'll write your business logic in Solidity, which will run on a virtual machine on each blockchain node. The cool thing about that is that the logic will have no effect on an underlying node functionality at all. So it remains stable. And that being said, you also sacrifice some speed and time. Let's see, in conclusion, though many treat blockchain as the next silver bullet, capable of solving many business tasks, the reality is a bit different. If your existing centralized solution works well in terms of speed, trust, maintainability, and security, you should think twice if you need a blockchain counterpart. However, if your existing solution is ineffective in a way, I'll put trust on the first position, speed and immutability on the chain. You can think about blockchain. Several bank consortiums, especially in Japan, boasted of increased transaction speed and clearing transactions after adopting the blockchain solution, as speed increased from a couple of days to a matter of seconds. Personally, I believe the blockchain is the next evolution, which happens right now. We just should make wise decisions when switching to it. Let's see exactly what this is. Okay, so yeah, it's just giving us another breakdown on the difference between public and private blockchains, which I think the last article did a very, very, very good job. Now, moving right along, we're going on 30 minutes on the podcast. We're going to be getting into what are the difference between public and private cryptocurrency. As we just read through that whole section, you can tell that the currency and the blockchain itself that it runs on are two totally different. We have certain cryptocurrencies that run on private currencies, that is, they run on public blockchains. So let's see what the difference between public and private currencies are. It goes on to say, once upon a time, Bitcoin was the beginning and the end of the cryptocurrency market. Today, while still the biggest, Bitcoin is merely one of the dozen important coins and tokens. From Ethereum to Bitcoin Cash to Particle to Salt, the market is flooded with other blockchain-based projects. Although many of these coins compete with each other in various ways, they are not all identical. Regarding privacy, they generally fall into two main categories: public and private. Public coins offer a degree of anonymity but focus on other areas. Others place privacy first and foremost. The first thing we're going to get into is anonymity versus privacy, because they are different from private and public. Before delving into the details of various cryptocurrencies, let's take a moment to consider how anonymity and privacy work in the blockchain world. All blockchain-based cryptocurrencies offer some degree of anonymity for users because they allow users to operate under pseudonyms. However, anonymity and pseudonymity are not the same thing as privacy. Bitcoin transactions can be traced, as can those for many other currencies and tokens that were not designed with privacy in mind. Addresses can be leaked, and transaction amounts can also be traced. If someone can reveal the true identity linked to an address, privacy totally disintegrates. Indeed, the very nature of a public blockchain, makes transactions traceable. All transactions that occur on an open blockchain can be viewed by any person that has access to the blockchain. The degree by which they are traceable depends on the cryptography employed by the project team. Public coins not focused on privacy tend to be linkable and traceable, while privacy coins use a variety of stealth tactics to break one or both of those characteristics. Public coins and utility tokens. True privacy comes with advanced cryptography and is why most of the cryptocurrency in use today offer no privacy features beyond basic anonymity, or rather pseudonymity. They are happy being public in the sense that traceable and linkable transactions on the blockchain doesn't affect the product or possibly the end user. Popular public cryptocurrency and tokens include Bitcoin, which is the cryptocurrency that put cryptocurrency on the map. Bitcoin offers anonymity. It does not offer much in the way of true privacy. Transactions are linkable and traceable by design. You have Litecoin. Litecoin was created as a response to what some Bitcoin users perceived as unacceptably slow transaction speeds storage problem. Compared to Bitcoin, Litecoin offers considerable improvement in transaction rates and storage efficiency. They just came out with an updated privacy characteristic of protocol also out of Litecoin. I should be doing a follow-up story to this one, going over that. Litecoin does not offer any major privacy features that aren't available in Bitcoin, as privacy is not a design goal. And once again, they have just came out with a new privacy feature with Litecoin. I'm gonna follow that story later on. Ethereum was conceived to extend blockchain use to areas beyond financial transactions. Ether is probably the most popular alternative to Bitcoin at the moment, but it does not offer any special privacy time. Then we have Ripple, XRP, which is a token development for use on the Ripple exchange. It also supports other cryptocurrencies. Ripple was pre-mined and then XRP was given away for promotion. And because Ripple is designed to provide resilience against attacks on the blockchain, XRP may become more popular as the threat of Bitcoin hacking increases. However, apart from resistance to hacking, XRP offers no special privacy features. Now we're getting into the privacy currency. Along the projects described above, there are popular tokens designed to be private by default, but hiding transaction details. These cryptocurrencies are still public in the sense that they have a public open ledger, but transaction information is obfuscated in various degrees to protect the privacy of the end user. And this is what I mean by there's a difference between a public blockchain and a private blockchain, and a public cryptocurrency and a private cryptocurrency. As we can see, we have private cryptocurrencies that are operating on a public blockchain. It goes on to say it is important to point out that there is a difference between secrecy and privacy. Every human has the right to privacy, and fighting for that right doesn't mean you have something to hide. Popular private cryptocurrencies include Monero. Monero provides privacy at all times through two features: ring signatures and ring confidential transactions, or ring CT. Ring signatures make it difficult to trace the parties involved, in a transaction because transaction signatures are shared by a large group of people. As a result, associated specific users with a transaction is very difficult. Ring CT, which technically speaking is actually a special type of ring signature rather than a distinct feature, provides additional privacy by obscuring transaction amount. Particle, Part, is a token created by Particle for use in its privacy platform and decentralized marketplace, which also supports many popular cryptocurrencies. Particle is a utility token with extremely robust privacy in mind. Built on the latest version of Bitcoin, Particle enhances the protocol with confidential transactions, or CT, and Ring CT. Like Monero, transactions are untraceable and amounts are unleakable. Unlike Monero, Particle gives the privacy control back to the user. The Part token provides multiple layers of privacy protection as it can seamlessly switch between public, and private while never leaving the owner's control and never compromising the right to privacy. I like how they said it. Remember, Dash, one of the first privacy-focused cryptocurrencies to emerge, which is also a trust. Dash, formerly Darkcoin, seems to prevent transaction tracing through a technique called coin mixing. Coin mixing is a third-party technique that may optionally be used with public cryptocurrencies, including Bitcoin, to add some privacy. But Dash incorporates mixing by default. The major criticism of Dash from a privacy perspective is that it depends on masternodes, which is not advanced cryptography, rather third-party mixers. If you don't trust the masternodes operators on essential servers, many reside on, it is difficult to feel confident in the privacy of Dash. And last, we're going over Zcash, which is privacy strategy is essential to erase the memory, that is the transaction history of coins whenever a transaction recurs. Like Monero and Particle, by obfuscating transaction history, Zcash makes it impossible to trace transactions. Zcash uses an advanced cryptographic technique called ZK snarks to make their coins private. And like Particle, Zcash is developing uses for its privacy beyond the currency. Although cryptocurrencies are often associated with the popular imagination with privacy, in reality, most cryptocurrencies provide only basic levels of pseudonymity. Essentially, crypto coins like Bitcoin offer the same level of cryptocurrency that you get if you buy something using cash in a store where no one recognizes you. In this scenario, your transactions are anonymous, but the transaction amounts can also be traced. And if someone is able to determine your identity, all privacy quickly evaporates. However, a handful of cryptocurrencies, such as Particle, fall into a different category. Designed to provide true privacy and not just anonymity, they provide special features which make it effectively impossible to trace users' identity, and for some of the coins, the transaction amounts. While some of these private cryptocurrencies have trade-offs, like masternodes in the case of Dash, that make them less attractive from a privacy perspective, others achieve privacy in a fully decentralized way. I got a short disclaimer. Particle is a client of BTC Media, which owns Distributed.com. The views and opinions, blah, 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 blah. So, family, that was a quick breakdown on the difference between public and private cryptocurrency. So we've gone through public and private blockchain, public and private cryptocurrencies. Now, last but not least, it's time to go over your public and your private key. And simply put, just in a nutshell, before I even have to read it, a public key is what you will get and you'll be able to share to any and everybody. Any and everybody is going to give you this public key in order for them to send you funds. Now, the private key is what you have to keep safe and secure, because that is a way that you access your funds or the return coding that you will receive from another recipient. So getting into the explanation given here on Komodo.com, the public and private key comprise of two uniquely related cryptographic keys, basically long random numbers. Below, and they show you an example of a public key, which is very long. The public key is what its name suggests, public. It is made available to everyone via a publicly accessible repository or directory. On the other hand, the private key must remain confidential to its respectful owner. Because the key pair is mathematically related, whatever is encrypted with a public key may only be decrypted by its corresponding private key and vice versa. For example, If Bob wants to send sensitive data to Alice and wants to be sure that only Alice may be able to read it, he will encrypt the data with Alice's public key. Only Alice will have access to corresponding private key, and as a result, is the only person with the capability of decrypting the encrypted data back to its original form. Meaning, if I send you something, we'll use Bitcoin in this instance, but we have to comprehend that Bitcoin is it is well within the how do I say? It's pretty much a code. We gave it a monetary value, but all you're sending is a code, and within that code, I can leave a message. Now, in order for you to decrypt that message or look at that code, you're going to need the private key of the platform or the wallet that I send it to. In order for you to, we'll use withdrawing funds, but it essentially is opening up the code and being able to look at it. They go on to say the only Alice has access to her corresponding private key, and as a result is the only person with the capability of decrypting the encrypted data back to its original form. As only Alice has access to her private key, it is possible only that Alice can decrypt the encrypted data. Even if someone else gained access to the encrypted data, it will remain confidential as they would not have access to Alice's private key. So meaning, someone may be able to see that you sent me $500, $5,000, $50,000 worth of Bitcoin, but they will not be able to access that said. They won't be able to access to the fullest extent the wallet that actually holds the cryptocurrency in order to withdraw it. You can easily look on it on a public blockchain and see, okay, they sent 0.0 whatever, yada yada yada. But without that private key, you won't be able to access that transaction or that code or that message. So, that is the simple breakdown in the differences between public and private within the cryptocurrency space. For anyone that is involved with the secure party creditor process or maybe into researching the difference between operating in a public and a private capacity in the commercial world of the United States, this is very, very interesting to say the least when we look at the way that the world of commerce is leading into, and that's the digital stage. So I hope this was helpful for anyone that was able to listen in on it. I may post a video that I did recording it. I may not. I may leave this a podcast episode. Nonetheless, family, I hope this was helpful. Until the next video, until the next podcast, this is Amir, the Chicago Crypto Hustler, Bitcoin Block Bully. Peace, power, and prosperity, family. I am out of here.